If you've ever driven past a big refinery or a chemical plant, especially at night, you've definitely seen it. That single, constant flame burning against the sky. It's a really common sight. But what is it actually for? Today, we're going to pull back the curtain on that mystery. So to understand that flame, we first have to wrap our heads around the incredible danger that's just constantly lurking inside these industrial plants. I mean, the number one job, day in and day out, is preventing a massive catastrophic explosion. Yeah, you've seen this, right? It's so easy to just assume it's waste, maybe some kind of pollution being burned off, but the real story is, well, it's way more critical and honestly a lot more interesting than that. It's a vital piece of a huge safety system. Okay, so try to picture one of these plants as this sprawling, complex network of vessels and pipes, and everything inside is operating under absolutely immense pressure. Now, if that pressure builds up and has nowhere to go, well, the consequences are just disastrous. The whole facility is basically designed to contain and manage this constant, powerful force. And this is its main job. That flame you see, it's not just some random byproduct. It's the final visible part of a system that exists for one reason: safety. Its whole purpose is to protect all that equipment from overpressure that could, otherwise blow the whole place up. It's not just a pipe, it's more like a guardian. So how does it all work? I mean, how does some extra gas from a pressurized tank all the way over there make its journey to the very top of that stack? Let's follow the path it takes. It's basically a four-step journey. First, the pressure has to be released. Then, all that gas gets gathered up into a network of pipes. After that, it goes through a really critical separation phase. And finally, it's burned off safely at the flare tip. Let's break down the most important parts of that trip. Step one is all about that initial release. See, all this equipment is fitted with these special valves. You've got your pressure safety valves, or PSVs, that just automatically pop open if the pressure inside gets too high. And then for the really serious emergencies, there are blowdown valves, BDVs, that can be triggered to dump pressure from the system super fast. They're the absolute first line of defense. Now, this next step in the journey is so important: separation. Before any of that gas gets burned, it's all sent to this huge container called a flare drum. And its only job is to separate out any liquids that might have gotten mixed in. The reason for that is pretty simple. Trying to shoot big slugs of flammable liquid hundreds of feet into the air to be set on fire, well, that's an incredibly dangerous idea. The flare drum makes sure only pure gas gets to the top. You might be thinking, a flare is a flare, right? But engineering is never quite that simple. Different plants and different situations call for totally different designs. Let's take a look at two of the big ones. So on one hand, you have your conventional flares. They release gas at subsonic speeds, slower than the speed of sound. But then you have sonic flares. These things are incredible pieces of engineering that actually blast the gas out at the speed of sound. This creates way better mixing with the air, which gives you a much more efficient, cleaner burn with less smoke. The only trade-off, they're a lot louder and have to handle way higher pressure. Let's just pause on that for a second. Mach 1. The gas leaving the tip of one of these sonic flares is literally traveling at the speed of sound. That incredible velocity is the secret sauce that makes the whole combustion process so clean and efficient. The engineering behind these systems has to be so precise because the stakes are just unbelievably high. And there's a pretty chilling real-world story that shows exactly what can happen when things go wrong, even when you think you're doing everything by the book. This was the question that investigators were wrestling with after a major disaster at a liquefied natural gas, or LNG, plant. And it all started on a quiet Christmas morning, during what was supposed to be a totally routine startup. Okay, so here's what happened. During the startup, the product they were dealing with was supercooled LNG. We're talking a liquid at minus 162 degrees Celsius. But instead of being sent to a special cryogenic storage tank designed to handle that cold, a mistake was made, and it was sent straight down the flare line. So as this unbelievably cold liquid hit the flare tip, it vaporized and ignited into this intensely hot flame. But that flame then made direct contact with the flare stack itself, which happened to be made out of a special type of aluminum. And here is the fatal flaw in the system. That specialty aluminum, it had a melting point of only around 220 degrees Celsius. Up against a flame from burning LNG, it just didn't stand a chance. The result was absolutely catastrophic. The flare stack literally melted and collapsed over a huge distance, tens of meters. It's just a stark, terrifying reminder of the extreme forces these systems are dealing with and why every single part has to work perfectly every single time. That story really drives the point home, doesn't it? The flare isn't just some afterthought. It is a meticulously engineered hero working right out in the open. So let's bring it all together. So when you boil it all down, this is what a flare system is actually doing. It's safely collecting gas, it's protecting equipment, it's separating out liquids, and it's preventing explosions by making sure there's a safe, controlled burn. Every single one of those is a vital safety function. And this, right here, is the single most important thing to take away from all of this. Seeing that steady, burning flame doesn't mean something is wrong or that a plant is being wasteful. It means the safety system is on, it's ready, and it's doing its job of protecting the plant, the people who work there, and the entire community around it. So I'll leave you with this question. The next time you see that flame on the horizon, now that you know the story behind it, the immense pressures it's controlling, that whole complex journey the gas takes, its role as the last line of defense, what will you see? An industrial polluter or an unseen guardian? I hope this gave you a whole new way to look at it. Thanks for watching.